Hello guys, welcome to our channel Wingx Sweft. I am Subha. Today, today's video I am going to show 3D printing workflow from idea to final product. So first of all, we understand the complete cycle of the idea to workflow, final product workflow. So first we have to need ideation, then CAD preparation, then material selection and technology selection, then slicing. After that 3D printing and post processing, finally we will get a final product. This is the complete cycle of 3D printing workflow from idea to final product. Let us start one by one what it is. Ideation, idea of any product. If you have an idea to make any product in your mind, first of all you have to draw a simple sketch of that product, whichever we are expecting, and whatever may be in your imagination. So first we have to make a, for example, a container box, a rough sketch we have to make. The next level is, if you see in the cycle, CAD 3D preparation. That means this is the digital model preparation which is required for, this is the input for the 3D printing. So we have to prepare like this. In the first ideation I have a sketch. Now we come to here, we have prepared a 3D model. I try to show you in 3D model how it will be in the CAD. So like this. So in the CAD model, computer aided design, in engineering software we can make this 3D visual model. So this is the model which we will use for. In the CAD we can check the interference, we can check how the behavior of the two parts, everything we can check in the CAD. This model is the input for the 3D printing. Okay. So I will try to show you in the CAD. This is the next CAD. So in which we have prepared this 3D model like this. So you can see how it is. This is a virtual real 3D model. So if you measure anything from here to here, whatever you have made with the dimension, those dimensions only will be it. The benefit of this is that we can see as a actual and realistically. So this we can export as STL, then we can use this model in slicing software. Okay, hope you understand what is CAD panel preparation. This is the CAD model preparation. After that, then we go for third, material selection and technology, where we have to select the material, then technology. Material, for 3D printing purpose we can use this many forms on this many materials. The plastics, powders, resins, metals, carbon fiber. This type of in this type of forms we can use it. Then in the plastics there is a PLA, ABS, PVC, PC. These all are the engineering thermal plastics. Then powder also, this is a form of powder. This is also like polyamide, this is nylon and aluminide. These are also plastics. Then resins, liquid form. Then these are metals like stainless steel, gold, nickel, aluminum, titanium. These are all the materials used for the 3D printing. These materials used in different technologies. In the 3D printing also different technologies are there. I will explain in the next slide. The carbon fiber also we can use. This is the form of chops like the chips. Okay. So I have selected for my example PLA plastic. This is the polylactic acid. So this is the material which I am going to use for my example. Okay. So I have selected material. Selection of material means I have selected here PLA as a material for my product. Then next, after selecting the material, then we have to select the technology also, because what are the material we are using, based on that technology also it will be depends. So in here there are many technologies, 8 technologies are there. So I will prepare in the next video about all the technologies, how it functions, everything. But in this video I have selected as a FDM technology. FDM is fused deposition modeling. I will explain you, I will show you how it works, the functionality also in the next slide. So I have decided to have a FDM technology because I am using a PLA. So PLA material can be used in FDM. So how it works I will explain you. Fusion deposit modeling, this is FDM, is a printing technology that creates objects by depositing material layer by layer involves melting a thermoplastic filament, typically ABS or PLA, and extruded it through a nozzle onto a build platform. As each layer is depositing and cools down, it fuses with the previous layer gradually built up by 3D object. See, I will show you how it will. This is the filament spool, in which you see here there is a filament. Actually this is actual one, this is the filament. This filament is a PLA filament. Then this filament will be come through extruder. This is the extruder, because it will be extruded, means by rotating these two wheels it will push toward the nozzle. This is the header, this is the nozzle, this is a nozzle where this filament from solid state to liquid state. This is liquefier. Here the material will be liquefied. That PLA having a 240 degree of melting point. So this we will set as in the program, we will set as a 240 degree centigrade. So automatically when this filament reach here in the nozzle, though this filament will be automatically liquefied for solid form to liquid form. Then through nozzle point, the material will be deposits here. This is the bed area. So this material deposit on the bed according to our model. So it will be deposit layer by layer, then it will each layer completion it will be solidified, the next layer will come automatically, it will be on the next previous layer it will be deposit. So both each other it will be bind together. So like that finally we will get a gradually it will build completely, then the 3D object will be formed. For example, I will show you in the machine itself. See, this is our actual 3D printer, APPM 3D printer. So as I said, material will be the filament will become like this. Here this extruder is there, the nozzle also is there, through nozzle also is there. In the nozzle there is a heaters. When the material reach there, automatically the nozzle will be in the 240 centigrade. Over there the material will be liquefied. Then it will layer by layer according to the object it will be printed on the bed. So finally according to your this all the parameters we will define in the slicing software based on the material. As I said, like PLA having a 240 degree centigrade, so it will be when it comes as a liquid it will be in the 240 degree centigrade. This is the bed temperature. Bed should not be in the cold condition, this should be having 70 degree, otherwise the material will be not able to stand on the bed. That's why to bond between a bed and a material first layer, so we have to maintain this one, and also it will be hold completely up to completion of the object and the printing. Okay, so this is how it works. This is the spool. I said this is a filament, the filament will become like this. Finally our object will be formed like this. Hope you understand about this fusion deposition modeling. Okay, the next level is we have already defined the technology and the material. Next level is this STL. As I said, in after completion of 3D CAD preparation, digital modeling preparation, we will export this 3D model to format of STL. This STL format we will import into slicing software. This is the slicing software. I will show you this also. This is the slicing software where we can make the program according to our quality requirement of the product. See, this is the place where I can put all the parameters. What is the layer height? See, this is the what is the wall thickness? What is the layer height? Layer means what is the layer? Layer by layer it will be produced the complete 3D project. So we have to define here what is the layer height, then wall thickness, parameters whatever required for that particular 3D object to form. All the parameters we can feed here. Like temperature, as I said, I will put 240 here, the bed temperature 270, like this. Then I will slice. I will slice means this will be prepared program for that ISO program for this. So in this software we have a facility to check how this behavior of layer by layer. See, all these things we can check and we can export as a G codes. So the G codes file will be formed like this. This ISO G code format can be read by the 3D printer. After making this print file, G code file, we'll take this into the USB or through Wi-Fi also we can connect to actual 3D printer. By using that we can print like this object. So like this only it is forming. So I have made a program by using STL file as a G code program. That G code program I have exported. I have taken the G code file into the USB or through Wi-Fi. We have connected to the 3D printer, actual 3D printer. So the 3D printer is readed that complete program and they have given product for us. The process, as I said, this is the 3D printing completed. Then next post process. Post is there. No? Post process is nothing. This is the pre-post part. That means when printing the product, actual product, there is a condition. If it is a more than 90 degree or 90 degree, it will prepare the supports automatically. Otherwise, it can't be print because it is in air, na. So that's why this is the software automatically will calculate which area is supposed to be need the supporters and some other requirements. So based on that, the software itself take care of all those supports and all, and it will be create a supporters. These supporters can be easily separate from the actual object. So this is the post process status. Pre-process status. This is the post process status. After removing this, the final product will be like this. So this is called a post process. Okay. Then final product. This is the final product. We have made a tube, as I said in the 3D model. This is my product which I have designed for my requirement. Then based on that only I have made finally. So if you see, whatever you have prepared in NX CAD, 3D model, digital model you can say. So similarly in actual also you are able to see how it looks. Okay. Then this is the standard, these all are the standard parts which is available on the market, and I need to fasten here. So I have fastened, I checked all the fittings, everything. This is like a prototype. I have made a prototype to make before going to make a mold for this, plastic mold for this. We have made like this prototype, and all the interferences and the aesthetics, looks, everything we have checked in real life within a span of very little time. Then we confirmed everything is there. If there was any adjustments are there, the modifications required, we have made it, and we have done within the small span of time, and we have made a die design as well as die manufacturing also. So like that we can utilize the 3D printing in your real life. Whatever you have idea to make, you just make the things and put on the paper, like say imagination, whatever you have, then prepare like this, then you select your material, then you select the technology which is available and according to your material. You can make the program, then run the program on the 3D printing, and make a post processor, then get your final product ready. Okay. Thank you guys. This is today's video. Hope you enjoyed the video. Please subscribe, share and subscribe, and don't forget to press on bell icon. Thank you very much. See you in next video.